Yo, what up everybody? We're going to be solving this triangle using our trigonometric identities. We're going to find the missing sides and the missing angle, and we're going to do this in under 5 minutes, so let's get started. Alright, so to start off, you might be confused because the angle over here is on the top and the angle shown in our model over here is on the bottom. Alright, so just be careful what side is which. We know that both of these angles here are made up of the hypotenuse, which is the longest side, and one other side. And that one other side we call adjacent, okay, as opposed to the opposite side, which would be across from this. The one side that's not touching it is the opposite side. So the adjacent side would be 15, right, over here, and then the opposite side will be corresponds to the A on this triangle. So we'll just put the A here, and the longest side is C, which is our hypotenuse. All right, so now these trigonometric identities will work for our example. One thing that might help you is if you just take this triangle and change the size of it, rotate it if you need to, but and then have it the same orientation as our problem. All right, so what do we have and what are we looking for? So let's start by looking for the opposite angle. And we have the B, we just need the A. And so which identity has both A and B? And that would be tangent. So we're going to use tangent, we're going to put in our angle, 65 degrees, and then we're going to put in our length of side B, which is 15. And so we have to solve this for A, and that will give us the length of side A. So how do we do that? A needs to be on a side by itself, so we're going to multiply by 15 to get rid of the 15 that's on the bottom of that fraction. Multiply 15 on both sides. You're going to cancel out the 15s on the right side, and that leaves you with this right here, tangent of 65 times 15. Now, if you need help putting this in a calculator, there's a little video you can click on and watch. But we're not going to do that in this video. If you take it to a calculator, it's going to tell you that it's 32.17, whatever the units are. Okay, that's the length of the side. Now we have one more side, and that's hypotenuse. All right, there's a possibility you could do this with Pythagorean theorem, but we're learning trigonometric identities, so we're going to stick with that. We want to find side C. We have side B, so cosine would be the right one for us. All right, so cosine 65 is equal to 15 divided by C. And we need to solve for C, and we can't do that when C is on the bottom of a fraction. So we need to get it off the bottom. And so we do that by multiplying by C, which causes it to cancel out on the right side, so it's no longer in the bottom of the fraction. And we have to multiply the other side by C, so it does appear over here. All right, we want C by itself, so we need to get rid of this term that's being multiplied to C, and so we do that by dividing by cosine 65 on both sides. And those cross out on the left side, and that gives us something that we can now put in a calculator. All right, and once you put that in the calculator, you should get this number right here, with a little rounding, 35.5. So there's our triangle. You can see, as expected, the hypotenuse is the longest side. And then this is a big angle, so the opposite side is almost as big as the hypotenuse, but not quite. All right, so it turns out how we expected. Now we just need to find the missing angle right here. And we know that the sum of angles has to equal 180. We have a 65-degree angle. We have a 90-degree angle. That's what that box represents. And so 65 plus 95 is 155. And we'll just have to see what is missing to make it up to 180. So subtract by 155 on both sides. Let's cross out. And you get that the missing angle is 180 minus 155, which is 25 degrees. And there we go. We've solved that problem. If you need help on other problems, feel free to click on one of these videos, as we have many more examples for you. Thank you.